Oxygen Blast technical seminars are an Intertech production. For instructor-led .NET, Java, and XML courses, visit us at www.intertech.com.
Hello, my name is Jason Shapiro, and this is the first chapter of Complete Java Web Development. This chapter is an overview of Java Enterprise Edition. So what exactly is Java Enterprise Edition? Java Enterprise Edition, or what I'll be referring to as Java EE through the rest of this chapter, is really a large platform, a large set of APIs that are designed to allow you as the developer to write big programs. Programs that deal with multi-tiers, with network computers, with large security, really anything that you're going to run in a large enterprise. Java EE itself is defined by specification and is managed by the Java community process. So that means because it's a specification, anyone could create their own Java EE platform as long as it adheres to the rules of the specification. Before you took this class, you probably learned Java SE, the standard edition. You're not going to throw that away. When you write applications in Java EE, you will continue to use the libraries and syntax that you learned from the Java Standard Edition. Java EE, in fact, is built on top of the Standard Edition. So it provides the Java SE provides the Java programming language, the core set of libraries, the virtual machine and runtime. Java EE is just going to add more stuff on top of this. Java EE is really big. There are quite a number of APIs that are available, API being an application programming interface or a library. So there's a large number of these available to allow you to build enterprise applications. It's very rare to be an expert in all Java EE. You tend to pick and choose the areas of Java EE that you'd like to focus on. So I've already mentioned Java EE and Java SE. There are really three editions to Java platform. So you have SE, you have EE, and you have ME. ME is the micro edition, which is really used for resource-constrained devices, such as cell phones and other consumer appliance devices. So the latest version of the Java Enterprise Platform is Java EE6. Previous to Java EE6, and really previous to Java EE5, the platform was known as the Java 2 Platform Enterprise Edition, also known as J2EE. In 2006, Sun, which is now Oracle, rebranded all of the Java platforms to keep this a little bit more simple. So they just got rid of the 2 in the name. Where we used to have Java 2 Standard Edition, or J2SE, it's now Java SE. Where we had Java 2 Enterprise Edition, or J2EE, it's now just Java EE. Same thing with the Micro Edition. It's now Java Micro Edition. So as I mentioned, Java EE is really big. It's a complicated solution to solve big and complicated problems. The purpose of Java EE is to give us these tools that we need to be able to solve these problems. So we're talking about things like distributed programming, transactions, performance, security. Really, if you're just doing a simple application that you're going to be using for your home, such as a little application to track kitchen recipes, Java EE is probably not the edition that you want to use. You'll probably want to go back to Java SE. Java EE is typically found in distributed multi-tier applications. So a tier is just simply either a physical or a logical location where some code with a specific responsibility is stored. Now it can be broken up into any number of tiers. N-tier architecture, you've probably heard that term. It means any number of tiers. But really, most application components live in one of 3 or 4 common tiers. So we would have probably a client tier, and that's what's going to run on the client machine. A web tier, which will run on the Java Enterprise Edition server. The business tier, which will also run on that Java Enterprise Edition server. And an enterprise information system tier, or a backend tier, and that's where your persistence and data is really going to live. There's a visual representation of that. So you can see we've got our client tier, our web tier, our business tier, and our backend tier. So these technologies and libraries which are provided help us develop components. And the components communicate with other components, and that's what builds up our entire application. There are third-party vendors and open source organizations that provide more technologies and APIs in addition to what we use with the Java EE platform. These will either extend or enhance some of the built-in Java EE capabilities. It provides us developers with more out-of-the-box stuff that we can do. And what does that do? That lets other people focus on sort of the plumbing and lets us focus on the business logic. So whenever you're going to write a program, whether it's with Java SE or Java EE, you're going to need to be able to execute that program in some kind of a container. So a container is a mechanism between a Java component and the computer platform that supports the component. It's going to provide lots of different lifecycle management, such as security, deployment, runtime services. In essence, a container is a Java virtual machine. So it's something that's going to be able to interpret your code, provide services, and then communicate to the underlying hardware, underlying operating system to be able to actually execute that code. By doing this, by having these containers, it allows you to do the write once, run anywhere, and also allow you to focus on your business logic rather than the low-level platform-specific computing details. Again, all Java components run in a Java container. So as you start to write applications, you'll find that different parts of your program will need to be run in various types of containers. There are really 5 main types of containers to support multi-tiered application. Now, I'm just going to list them off right now, but we'll look at each of these in a little bit more detail here in this chapter. You have an applet container, an application client container. Both of these are going to be run on the client tier. There's the web container, which will run your servlets and JSPs, and those live on the web tier. You have your enterprise Java Bean container if you're writing any EJBs, and that lives on the business tier. Or if you'd like, you could run a Java EE server, which will contain both of your web and EJB containers. So if we put those containers in the previous slide, you can see visually where they live. Again, your application client container and your applet container are on the client tier. We have our web container on the web tier, the EJB container on the business tier, and then an app server, a Java EE server, which would contain both the web container and the EJB container. So let's start by looking at the application client container. That's really your JVM, your Java Virtual Machine, or your JRE, your Java Runtime Environment. The difference between the JRE and the JVM is the JRE contains a JVM along with the Java API. So application client components run on a client container. When you write a standalone application, or what's known as a fat client application, that will typically be run inside of the Java Virtual Machine. If you're writing something with a GUI using the Java Swing API, again, this will be run inside of the Java Virtual Machine for the Java SE edition. The JVM can provide client-side access to server-side Java components, so you can still communicate with EJBs and web services. It's just that that functionality will not be executed inside of this container. It will simply allow the communication. Applet containers are found inside of browsers, and they're not as popular as they used to be. There's a lot more technologies that are out there, and of course HTML itself has improved over time. But really, applets are the ability to write Java programs and have them execute inside of a browser. Applets are very restricted. They have far less access to the underlying machine than an application client container. So they don't have the ability to be EJB, JMS, or RMI clients. This is a sandbox, and the sandbox exists to help prevent malicious code, for having some applet that's downloaded and then being able to wreak havoc on someone's machine. The web container manages the execution of JSP pages and servlet components for Java EE applications. So really, anytime you're going to write a servlet, anytime you're going to write a JSP, it must live inside of a web container. The web container is not only going to know how to run these particular programs, it's going to have hooks. It's going to know which method should I call when a request comes in. What should I do with that incoming request to change it from a text HTTP packet into some sort of an object that your particular program could use. So there's a lot of different services for the lifecycle of your web application that the web container will take care of. Likewise, the EJB container will support enterprise Java beans. EJBs typically contain reusable business logic, and they may serve other middleware components or client applications. And although it's possible to use containers that are separate for your Java web and your Java EJB components, typically they're put together in what's known as a Java EE server or an application server. Some popular application servers include WebSphere, WebLogic, JBoss. All those are application servers which support both web and EJB.
For more free learning resources and to see the latest lineup of our instructor-led .NET, Java, and XML courses, visit us at www.intertech.com.